In this video, we're going to learn how to calculate the volume of a cone. To be more specific, we'll be learning how to calculate the volume of a right cone, which I'll define in just a second or two. Now, in the upper left-hand corner here, we have a right cone whose volume we'll be calculating in just a minute. But before doing so, let me start by stating the formula for calculating the volume of a right cone. So let's see, I'll make a quick sketch of a right cone, so it will look something like this, with the disk at the base. And the center of the disk is right here, and that disk has radius r. Okay, now first let me get something out of the way. A right cone is a cone in which the segment joining the vertex of the cone to the center of the base, so that would be this segment here, forms a right angle with any radius you draw at the base. And to put things simply, at middle school or high school, unless explicitly told otherwise, the cones that you'll be working with will be right cones. So the one we have on the left-hand side here is a right cone. That being said, I carry on. Given a right cone whose base has radius r, and whose height, so that would be this length here, whose height is h, its volume is equal to 1/3 times pi r squared times h. And I'll go ahead and box that formula. That's the formula for a right cone's volume. And looking at this, we can see clearly that to calculate any right cone's volume, we'll need to know the radius of the disk at the base and the height of the cone, which is exactly what we're given in the example we have here. So let's go ahead and calculate this cone's volume. And I'll just quickly write volume. Okay, so the volume is given by our formula, so capital V is equal to 1/3 times pi r squared times h, and I'm replacing the r that we have in this formula by 5, since the radius is 5 centimeters, and the h we have here by 13. This becomes 1/3 times pi times 5 squared times 13. And now, if you're allowed to use a calculator, then you could just type all of this into it and get the answer directly. But the answer you'd get would be rounded. And so if ever you were asked for either the exact volume, or you were asked to write your answer in terms of pi, here's how you would carry on. First of all, we can write this entire product as a single fraction. Indeed, all 4 of the terms we have at the top here will all end up on the numerator, and the 3 that we have here will be on the denominator. In other words, this can be rewritten as 1 times pi times 5 squared, which is 25, so I'll quickly write that, that's 25, times 13, and all of that's written over 3. Next, remembering that the order of the terms in a product doesn't matter, I multiply the 1 with the 25 and the 13, and you can go ahead and check, but 25 times 13 is 325. So on the numerator here, we'll have 325 times pi, which we write 325 pi. And that's 325 pi over 3. And as such, that's the exact volume. And since we're working with centimeters here, this would be 325 pi over 3 cubic centimeters. And I'll go ahead and box that result. That's this right cone's exact volume. But as I said, if we're allowed to use a calculator, then for all practical purposes, we would type this line of working on our calculator to get the result. And in doing so, and rounding to the nearest cubic centimeter, I find that this right cone's volume is 340 cubic centimeters. And we're done. That's how we can calculate the volume of a right cone.